So we're on section 5, which is the Fibonacci sequence and the golden ratio. So we're going to just look at the first 6 problems, which are kind of questions. So the Fibonacci sequence basically says that if you start out with 2 1s, and if you add 1 plus 1, you get 2, and then you add the next 2 numbers. 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, etc., etc. So you just continue on in that pattern. So for problem number 1, it says the 16th Fibonacci number in the Fibonacci sequence is 987. It says the 17th is going to be equal to 1597. So what's the next one, which is the 18th? Well, if we have the 16th and 17th, the 18th is just by adding those 2 together. And if we add that in our calculator, we get 2584. And then we could do the next, if we add this plus that, we would get, so the next number in the sequence would be 1597 plus 2584, which would be 4181, etc., etc. You can go on forever. Okay, problem number 2. I just accidentally turned my stylus thing off. Okay. Number 2 says, recall that f sub n represents a Fibonacci number in the nth position in the sequence. What are the only 2 values of n such that f of n equals n? Well, let's just write them out when we had them written out here. I don't know how I can get this thing to stop doing that. What's going on here? Okay. Don't know how that happened, but anyway. So there's only 2 numbers that happens to. And this is F1, this is F2, F3, F4, and F5. So we can see this one is case 1 and 1 and 5 and 5. And if that's the only 2, then we're done. Number 3, if F22 is equal to 17,711, and F24 is equal to 46368, then what is F23 equal to? Well, we know that F22 plus F23 equals F24, so we can solve for F23. It's going to be F24 minus F22. So we have 46,368 minus 17,711. 46,368 minus 17,711, and we get 28,657. Number 4, if 2 successive terms of the Fibonacci sequence are both odd, what is the next term, odd or even? Well, if you add 2 odd numbers together, you always get an even number. If you add 2 even numbers together, you get an even number. If you add an odd and even, you get an odd. So the answer is it's going to be even. What is the exact value of the golden ratio? Well, it's in your book. It's 1 plus the square root of 5 over 2. And what is the approximate value of the golden ratio? Well, the approximate value would just be to plug that in your calculator and see what number you get. So you get 1 plus the square root of 5, the whole thing divided by 2, and you get 1.618. And remember that this ratio is just the ratio of taking subsequent terms in the Fibonacci sequence. So if I were to take this F24, so if I take F24 and I divide it by F23, you get 46,368 divided by 28,657. See what we get. 46368 divided by 28657, and I get 1.618. And I'm actually looking at the exact value. This is the approximate value, but let's write out too many decimal points as the calculator will do. So that's that. And if you could take this out, you get 0.33988. So these are exactly equal, except this last decimal point out of 10. So that's a pretty small variation once you got to F23 or whatever. Of course, if you do F, if you did the first couple, you have 5 and 3, and you have 3 and 2 and 2 and 1. These are the ratio. So this is 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. So then you'd have 8/5. And if you do this, you get 2, 1.5, 1.6. 8/5. 8 divided by 5 is 1.6 also. Actually, this is 1.66. So this is 1.66666. This is 1.6. To the next one, it would be, add these two together to get 13. 13 divided by 8. 13 divided by 8 is 1.625. Add these two to get 21. 21 divided by 13 is 1.615. So you can see it's approaching this number. It doesn't take that long for that to happen. So it's kind of a cool number. Okay, in exercises 7 through 14, a pattern is established involving the terms of the Fibonacci sequence. Use inductive reasoning to make conjecture concerning the next equation in the pattern and verify it. So let's do 2 of those, and then we'll start a new video. So 1 is equal to 2 minus 1. 1 plus 1 is equal to 3 minus 1. 1 plus 1 plus 2 is equal to 5 minus 1. 1 plus 1 plus 1 plus 2 plus 3 is equal to 8 minus 1. 1 plus 1 plus 2 plus 3 plus 2 plus 3 is 5. You skip over 1, which is, so you get 8. 8 plus 5 is 13, so it'd be 13 minus 1. So these are the numbers in the Fibonacci sequence. So the next one, by conjecture here, by using inductive reasoning, we 1 plus 1 plus 2 plus 3 plus 5 plus 8 is equal to, not 8, yeah, 8. And so we skip over we go to the next one, which is 21 minus 1. So we get 2, 3, 5, 8, 13, 21. And let's just confirm that. So that's what we use by inductive reasoning. We add these together. So we get 1 plus 1 is 2, plus 2 is 4, plus 3 is 7, plus 5 is 12, plus 8 is 20. 21 minus 1 is 20. So that works. Okay, let's do number 10. So number 10 says 1 squared plus 1 squared equals 2. 2 squared, 1 squared plus 2 squared is equal to 5. 1 squared plus 2 squared, the next term in the Fibonacci sequence would be 3. And then we're going 2, 5, 13. So we're kind of skipping. If we put a 3 in here, 2, 3 is 5, 2 is 8, and then that would be 21. 21 plus 13 would be 44. Is that right? 13, 21, 30, 34. So we'd have 1 squared plus 2 squared plus 3 squared plus 5 squared. Oh, no. Okay. Yeah, I'm getting carried away here. I'm not following the pattern. So it's the last two numbers. So this is 2 and 3. So the next one would be 3 and 5, I guess. Okay. These are all in your book. I was trying to do it in my head. Okay, so that's equal. So the next one would be 5 squared plus 8 squared. And we skip one here. So 21 plus that is 55. 55 plus 34 is 89. So that would be equal to 89. Is that right? Yep. Okay. So the next one would be 8 squared plus, and the next number was 13. So 13 squared is equal to, well, we have this intermediate one, which would be 4, 14, 1, that'd be 144, I guess. Is that right? 13 plus 1 is 4, 144. And so then we add these two together, and so we get 9 plus 4 is 13. 8 plus 4 is 12, carrying 1, so you get 12 plus 1 is 13. And then we have another one, which would be 233. So let's see if that's true or not. So we're checking it by adding these two numbers. So 8 squared is 64. 13 squared is 169. And if we take 64 plus 169, we get 233. Just saw a snowplow go by. I don't know why, because it's really not snowing that much. But okay, so I'm going to do another one of these, but we'll do it. We'll do it in the next video.